Right. So next we have what? 11 part B. So this is the factor remainder theorem and polynomial question. So fx is a degree 3 polynomial, and when that polynomial is divided by these divisors, there's 3 divisors. For each case you get the same remainder 11x minus 6, and one more thing is given, f of 0 is equal to 0. So that means what? That means x equals 0 is a factor. Then we need to find fx. So then let's see. So how to do this? There are several ways of doing this. We'll do it. Okay, right, right. We'll do it like this. We'll take, this is a degree 3 polynomial. No? So then it has to have this form, no? Ax cubed plus bx squared plus cx plus d. Right. Then we have to find a, b, c, d. Right. Easiest thing to find is d. D is going to be 0. Reason is why? F of 0 is 0. No? F of 0 is 0. Then we get what? D is 0. So then the cubic we want to find has this form, ax cubed plus bx squared plus cx. So basically this form, because x is a factor, no? X equals 0 is a solution. So this is the form of our cubic, right? Then to find the other 3 values we have to use what is given here. So fx, that is this one, ax cubed plus bx squared plus cx, when it is divided by this one, x squared minus 3x plus 2, the remainder is 11x minus 6. So this is using the division algorithm. We can write it like that: quotient into divisor plus remainder is equal to the function, right? So then we need to create 3 more equations because we have 3 unknowns, no? So this divisor can be factored, x minus 1 and x minus 2, right? So now you can substitute x equals 1 and get one equation, and similarly substitute x equals 2 and get another equation. When x equals 1, this becomes 0, and you have a plus b plus c equals 5. Then substitute x equals 2, then you get what? 8a, 4b, 2c equals 16, right? 22 minus 6, equation 2, right? Right. Then we'll use the next one, next divisor. So then you can write ax cubed plus bx squared, our function, equal to a new divisor q1x. So new quotient also, and the divisor is what? X squared minus 5x plus 6. So I will write it in the factored form, x minus 2 into x minus 3 plus 11x minus 6. It also has the same remainder, right? So we just need one more equation, no? So substitute x equals 3, x equals 2, you get the same equation back, no? So no point in substituting x equals 2. Substitute x equals 3, so you get 27a. So substitute x equals 3 into this, and what you get? 27a, 9b, 3c, equals 33 minus 6, which is 27, right? So you can divide by 3. So 9a 3b plus c equals 9. So that's your third equation. Right, now solve them simultaneously and get the answer. So I will do 3 minus 1 first. So then 3 minus 1 gives you 8a 2b, c is cancel, 8a 2b, c is cancel, 9 minus 5 4. So 4a plus b equals 2. Equation 4. We'll need to create another one. So we'll do what? We'll do second one minus first one multiplied by 2. Second one minus first one multiplied by 2. So then 8a minus 2a 6a, 4b minus 2b, 4b minus 2b is 2b, c is cancel, 2c and 2c cancel, 16 minus 10 is 6. Simplify, 3a plus b equals 3. Right, solve 4 and 5. So what do you get? Simultaneously, so you can do 4 minus 5, a equals minus 1, then b equals a equals minus 1 means b equals 6, right? A equals minus 1, b equals 6. Then what is c? You can use the first equation. A plus b plus c equals 5. So minus 1 plus 6 plus c equals 5. So c equals 0. Okay. Then what do we have? C is also 0. So the equation is what? Ax cube plus bx square. So a is what? So our function we were looking for is minus x cube plus 6x square. C is 0, right? So that is the cubic we want, right? So that part is done. Then the last part is what? The curve, fx curves gradient. The maximum value the curve of fx gradient can take is 12. So you have to show that gradient of fx, the maximum gradient of fx curve can take is 12. Gradient depends on what? Derivative. So find the derivative of fx. So f dash x is what? Minus 3x squared plus 12x, right? Minus 3x squared plus 12x, right? So maximum value derivative can take is the gradient, maximum value of the gradient. So this is a quadratic. No, you can do what? Complete the square or use stationary points to check whether the maximum value is 12 or not, right? So I will just complete the square. It's easy. Minus 3 you can take out, so x squared minus 4x, so you have minus 3, x minus 2 whole thing squared minus 4, right? So what do you get? F dash x is what? Minus 3 x minus 2 squared plus 12. So this is the gradient, no? Gradient function. So what's the highest value? Maximum value the gradient function can take is 12, because this part, the first part is always negative, greater less than or 0. So this is always going to be less than or equal to 12. So max f dash x is 12, which is the maximum gradient. So that is what we needed to show for the last part, right? So that is question number 11. Next we'll do question number 12, part A.